All right, this video is going to cover the solutions to the midterm, or sorry, the final exam review packet for Precalc. So if I start with the first one, this is your simplifying of identities using your Pythagorean identities and reciprocal identities, that kind of thing. So if I were to take secant and replace it as 1 over cosine, and then I can actually bring this secant to the top, and I'd make it cosine. So when you bring a function to the top, it becomes its reciprocal function. So with two separate fractions, I would want to combine this into one. I want to give this the denominator of cosine. So if I have to multiply the bottom by cosine, I have to do the same in the top. And I end up with 1 minus 1 over cosine x minus cosine squared x over cosine. Combine those into 1, I get 1 minus cosine squared x over cosine. And one of our Pythagorean identities is that sine squared plus cosine squared equals 1. So this 1 minus cosine squared is sine squared over cosine. And then I can actually pull out a sine. And I've got 1 more over cosine, which this then becomes sine x times tangent x. And that's as simplified as you can get it. Okay, now we're going to look at number 2. So this is cosecant x times sine x plus cosine. So cosecant's the same thing as 1 over sine of x. If I multiply that times sine of x plus cosine of x, I would distribute this in, and I'd get 1 over sine times sine, which is sine of x, over sine of x, plus 1 over sine times cosine, which is cosine of x, over sine of x. This becomes 1, and cosine over sine is cotangent of x. Okay, so now we're going to look at 3 and 4, which are the sum and difference identities. So if you look at your reference sheet, which I've got down here, you've got addition and subtraction formulas. These are the same as sum and difference, and you'll pair this with the unit circle, which I also brought in to help out. So if I go to cosine, and this is a minus, cosine minus is here, which is cosine, cosine plus sine, sine. So I do cosine of the first, which would be cosine of 150, cosine of the second, which would be cosine 45, change the sign so it's plus, and then you do sine of the first, so sine of 150, sine 45. Okay, then I come to my unit circle. So 150 is here, and the cosine is the x-coordinate. So this is negative root 3 over 2. 45 is here. Cosine is the x-coordinate, root 2 over 2. Sine of 150, I come back to here. The sine's now the y, which is 1/2. And the sine of 45 back over here is root 2 over 2. So if I multiply this out, I get negative root 6 over 4 plus root 2 over 4. If I combine it, I get negative root 6 plus root 2 over 4. Usually on standardized tests, you'll see it factored out, so they'll take out a root 2, and you would get negative root 3 plus 1 over 4. So because this is multiple choice, just make sure you know that when you get to this answer, it's the same as this one. Okay, now we're going to look at 4. So this is sine of 15. This time you've got to figure out what two angles would either add up together to give you that angle or subtract, which in this case I would do subtraction. Obviously 15 is pretty small. You can't add two angles that are in the unit circle together to get 15. But I can take something like 60 and then subtract 45 from it. I could have done 45 minus 15. Anything like that would have worked. So in that case, I go here for my sum and difference, sine of a minus, which would be this one, which is sine of the first, cosine of the second, and you keep the sign the same for sine, and then cosine of the first, sine of the second. Go to my unit circle, and I'm using 60 degrees and 45 degrees. So the sine, or the y, of 60 is root 3 over 2. The cosine of 45 is root 2 over 2. Cosine of 60 is the x of 160, which is 1/2, and the sine of 45, which is root 2 over 2. So I'd get root 6 over 4 minus root 2 over 4, root 6 minus root 2 over 4. And again, take out that root 2, and you get root 2 times root 3 minus 1 over 4. All right, now we're going to look at the next group, which is find the solutions of the equation. So this is cosine and sine. You want to work to get the trig function on the side by itself, then use the unit circle to figure out where that occurs. And then because it doesn't give an interval here, I always make sure that when it's sine or cosine, I add 2 pi k or 2 pi n. So for number 5, I want to get the cosine by itself. So 2 cosine would equal negative root 2, divide by 2. And I'm looking for where on my unit circle cosine is negative root 2 over 2. Because the cosine is x, I'm looking for where on the unit circle. The x is negative root 2 over 2, which happens here and here, which would be 3 pi over 4 and 5 pi over 4. And then again, there's no interval. So I add 2 pi n or 2n pi to both of those solutions. Okay, now I'm going to look at 6. So 6 again, I want to work to get the sine on the side by itself, and it already is. I'm looking for where sine, which is the y, is 0, which occurs here at 0 and at pi. And with sine, we take those two and we add 2n pi or 2 pi n to both of the solutions. Okay, numbers 7 and 8 are your right triangle trig questions. So 7 says a radio transmission tower is 250 feet tall. So if I drew a tower, it would be 250 feet tall. How long should a guy wire be if it's to be attached 12 feet from the top? So you've got a wire that starts 12 feet from the top and makes a 30-degree angle with the ground. And it wants to know how long that wire should be. So it's going to be x. So if I were to set this up, the first thing I would need to do is subtract the 12 from the 250, making this 238. And then that's the opposite side, and x is the hypotenuse. So that's sine. Sine of 30 degrees would equal 238 over x. And then when the number's in the top and the variable's in the bottom, I take the number and divide it by the trig function. So x would equal 238 divided by the sine of 30. And you definitely want to be in degrees for these kind of problems. So if you just type that in the calculator, you would get 476, and it's in feet. Okay, so number 8, from a boat on a lake, the angle of elevation to the top of a cliff is 24 degrees and 22 minutes. So I've got a boat on a lake. From here to the top of the cliff would be 24 degrees and 22 minutes. If the base of the cliff is 747 feet from the boat, how high is this cliff to the nearest foot? So this time I have opposite and adjacent, which would be tangent. So the tangent of 24 degrees, 22 minutes is x over 747. And then I would multiply this by 747. So if your calculator has the little degree and tick mark symbol, then you can type it in the way that it is. If not, then I would take that 22 and divide it by 60 and get a decimal first, and then add that to 24. Multiply it times the 247 and round to the nearest degree, and you should get 338. Okay, now we're going to work with the law of sines. So number 9 says solve the triangle, and it gives you the triangle with 2 angles and one side. So with law of sines, you'd have to find this third missing angle. So I would do 180 minus 75, which is 105, minus 50, and I get 55. So I know that angle, which is part of what I'm looking for, angle B, 55 degrees. Okay, so with law of sines, I want to use one complete ratio, which we've got B. So I can use B over the sine of B would equal C over the sine of C. And b over the sine of b is going to equal a over the sine of a. So take and plug in what you've got. B, which is 7 over the sine of b, would equal, or sorry, that which is 55, would equal c, which we're missing, over the sine of 75. Cross multiply. And divide. And I'm going to keep this rounded to 2 decimal places. So side C would be 8.25. So now I've got angle B and I've got side C. And then I'm going to work to find angle A, or side A. So B, again, is 7 over the sine of 55 would equal A, which is what I don't know, over the sine of 50 degrees. Cross multiply. And divide. So 7 times the sine of 50 degrees divided by the sine of 55 degrees gives me A, which is 6.55. Okay, now we're going to look at 10. So 10 gives you 3 sides. In this case, you're going to use the law of cosines. Law of cosines tells you to start with the largest angle first. So I have to start with angle C. And I would say that the cosine of C equals A squared plus B squared minus C squared over 2AB. So A squared is 6 squared. B squared would be 4 squared, and C squared is 7 squared over 2 times 6 times 4. You can type that all in the calculator, or you could break it apart piece by piece. So 36 plus 16 minus 49 gives you 3. And then 2 times 6 is 12, times 4 is 48. From there, I would do 3 divided by 48 in the calculator, and then I would do cosine -1 of 1/16, or leave it as that, and you end up getting that cosine, or sorry, that angle C is 86.4 degrees. Okay, now we can either continue with law of cosines, or we could switch to the law of sines, since we've got one complete angle. So I'm going to stick to law of cosines just so that we can practice it a little bit more. But we definitely could have switched to law of sines. So let's do cosine of A now. So A would be B squared plus C squared minus A squared over 2BC. So 4 squared plus 7 squared minus 6 squared over 2 times 4 times 7. And then 4 squared, 16, plus 7 squared, 49, minus 36 is 29. And 2 times 4 is 8, times 7 is 56. So again, in the calculator, do cosine -1 of 29 over 56. And I would get angle A is 58.8 degrees. And the direction said to round to the nearest degree. So angle C would be 86 degrees. Angle A would be 59 degrees. And then if I add those and subtract them from 180, I get angle B, which is 35 degrees. Okay, so now we get into vectors. So number 11 says to find U plus V. This is in IJ format, so I can simply just combine my like terms. -2I and -6I is -8I, and -6J and +8J is a +2J. If it gives it to you in IJ format, you want to make sure that you leave it in IJ format. U minus V, so I simply just change the sign. So negative 4I minus 6I gives you negative 10I. And then negative 2J minus 7J is a negative 9J. Okay, now we're doing the dot product. So when I do the dot product, when I multiply vectors, it's called the dot product. You don't really just multiply. You're going to multiply the first times the first. So the first thing you might want to do is get this into vector format, which would be negative 8, 5, negative 11, negative 6. And then I do first times first, so 8 times negative 8 times negative 11, which is 88, plus second times second, which is 5 times negative 6, which is negative 30. And you get 58. Okay, so 14 is negative 5 times U with the dot product of V. So the first thing I'm going to do is get these into points. So negative 2, negative 7 is U, and 4, negative 9 is V. Multiply this times negative 5, and I end up with 10, 35, and 4, negative 9. So 10 times 4 is 40, plus 35 times negative 9, which is 3, 15, and then add those two together, and I get 3, or sorry, that's a negative. Should be a negative 315. And I end up with a negative 275. All right, so now we'll do the angle between the two vectors. So this equation is on your reference form, but it is the dot product, or the cosine negative 1, actually. Cosine negative 1 of the dot product of U and V over the magnitude of U times the magnitude of V. So if I take this negative 1, 2, and 5, negative 6, the dot product would be negative 1 times 5, negative 5, plus 2 times negative 6, negative 12. So the dot product is negative 17. Magnitude of U, so I would do A squared plus B squared underneath the square root. So square root of negative 1 squared plus 2 squared. 1 plus 4, and I get square root 5. Do the same thing with V, square root of 5 squared plus negative 6 squared, which is 25 plus 36, or the square root of 61. And then in the calculator, you can go one step further and you can multiply that 5 times the square root of 61. It might be easier. So and then I would do the cosine negative 1 of 17 over the square root of 305. And from that, you get 166.76 degrees. All right, so we're going to stop the video there for part 1, and then I'm going to pick up with the partial fraction decomposition for part 2.